All right. Our last subtopic, mutual inductance. Okay, so in this subtopic, you just have to be able to define what is mutual inductance. Use mutual inductance between two coaxial solenoids. Okay, mutual induction. Let's consider two circular close-packed coils near each other. So this is coil one. This is coil two. So they are sharing a common central axis lah. Central axis. As current I1 flows in coil 1 here, it will which is produced by the battery here, the current will produce a magnetic field lines, which is this one. This is the magnetic field lines, and this field lines will also passes through this coil 2. Okay, so if the current will be changing with time, the magnetic flux through coil 1 and 2 will also change with time simultaneously. Okay, so due to the change of magnetic flux through coil 2 here, there will be an induced EMF produced in this coil. Okay, this is following the Faraday's law of induction lah. Okay, so in short, a change of current of one coil will lead to the production of an induced EMF in the second coil, which is magnetically linked to the first coil lah. Okay, so this is the process that is known as mutual induction. Okay, so if you need to explain what is mutual induction, this part is the answer lah. Okay, it is due to the current produced by a battery in the first coil, so there will be a magnetic field, and this magnetic field will passes through the second coil, and if the current is changing with time, there will be a change in this magnetic flux of coil 2, hence there will be a production of an induced EMF lah. Okay, so that is what we known as mutual induction. Okay, so mutual induction definition is the process of producing an induced EMF in one coil due to the change of current in another coil. Okay, at the same time, the self-induction occurs in coil 1 since the magnetic flux through it changes lah. Okay, now mutual inductance pula, symbol is M. So based on the figure just now, which is this one here, the let's consider the coil 1 and 2 will have this will have N1 and N2 turns. Okay, so if the current I1 in coil 1 here changes, the magnetic flux through coil 2 will also change with time, and an induced EMF will occur in coil 2. So di sini ada induced EMF. So how do we calculate the magnitude of the induced EMF is by using this equation here. So M is known as the mutual inductance lah. Okay, so if vice versa, the induced EMF in coil 1 is given by this equation pula. Okay, so the mutual inductance for coil 1 and coil 2 is actually the same, so we can just label them as M saja. Okay, so it is a scalar quantity and its unit is Henry. So the definition of mutual inductance is the ratio of induced EMF in a coil to the rate of change of current in another coil. Okay, so from the Faraday's law for coil 2, we can then conclude that the induced EMF for the second coil is this equation here. So this one kita substitute dengan equation with if this equation here. So from here we can then get the mutual inductance for coil 1 to 2 to be this one, and the same one as this. This is for coil 1, this is for coil 2 lah. Okay, so in short, you can actually calculate mutual inductance for the two solenoids by using this equation here. Okay, but how do we obtain that is, let's look at this one. Okay, so consider a long solenoid. So this is a long solenoid and cross-sectional area A closely wound in N1 turns of wire. A coil of N2 turns is this one around its center. Okay, so when a current flows in the primary coil, which is the black wire, it produces a magnetic field of B1. So we obtain this one, and then the magnetic flux is just this equation here. So if there is no magnetic flux leakage, okay, so there's no leakage, there's no loss of magnetic flux, we can let the magnetic flux of coil 1 to be equal to the coil 2. Okay, so if the current changes and EMF is then produced in the secondary coils, which is the orange circuit, a orange wire. So the mutual inductance will then occur, so we can calculate the magnitude by using this equation here. Okay, but if it's asking about one of the coils jet, then we are gonna use these equations here lah. Okay, all right, so I guess that is the end of our subtopic 5.5, which is on mutual inductance, and that is basically the end of our chapter 5.